Hello, everybody. It's Mrs. Pound, and I am back with more from Chapter 6.2 on sound. This is going to be a really short chapter. After this video, there's only going to be one more video. So today, what we're going to focus on are speed, frequency, and intensity. So our objectives today are to relate amplitude to intensity and loudness and explain how frequency corresponds to pitch, and also to summarize the Doppler effect. So the speed of light is really fast. It's 299,337,984 meters per second. Super fast. The speed of sound is only 346 meters per second. So light waves travel much faster than sound waves. And that is why you can calculate the distance lightning strikes from you by the difference in when you see the lightning, which is pretty much instantaneous, to when you hear it. Because the farther away it is, the longer it's going to take to get to your ears compared to the time it takes to get to your eyes. And so that's why we can do that. Now, let's talk about the amplitude of sound waves. Now, remember, sound waves are longitudinal waves. So we're talking about compressions, the molecules being close together and squished, and rarefactions where they're more spread out. So a high amplitude sound waves have dense compressions and sparse rarefactions. So this we can see is very dense compared to this. Low amplitude sound waves have sparse compressions and dense rarefactions. We can see in this picture, there's a little less difference between the compressions and rarefactions. They're closer together. So that would be lower amplitude for a sound wave, as opposed to with our transverse waves where we had the big crest and the deep troughs. So that's how amplitude differs for longitudinal waves compared to transverse waves. Now, intensity is the average rate of energy that flows through a defined area. So the more energy going through, the more intense. And the greater the amplitude, the greater the energy. So when we have a higher amplitude, we have more intensity. Now, distance affects the intensity of sound waves because sound waves contain a certain amount of energy. They only have so much. When the sound wave is produced, it transfers some of the energy to surrounding objects. So through the air, to the grass, to the road in this case. If a sound wave does not contain an adequate amount of energy, the intensity of the sound waves is diminished and the wave cannot travel far distances. So after a while, if you're yelling, after a while, the energy is just absorbed by other things and people will not hear you. So let's talk about intensity versus loudness. Now remember the definition for intensity is the average rate of energy that flows through a defined area. This value is measurable. Okay, we have instruments that can measure that. Loudness is the way a person perceives the intensity of sound waves. It is subjective. It is different for different people. What seems very loud to one person may not seem loud to me, especially because I have a little bit of hearing loss, I admit it. Um, so something that seems very loud to you may not be loud to me, or, somebody who does use hearing aids, it may not appear loud to them. So that is subjective. That's what subjective means, is that it's different for different people. Both are determined by the amplitude of a sound wave. So as far as even though a sound may not appear as loud to me as it does to you, different loudnesses will have different amplitudes, and the higher the amplitude, the louder the sound will appear to me. Now, if you are exposed to high intensity sounds, but they do not hurt, your hearing can still be damaged. That's why you really have to be careful with things like your earbuds, headphones, loud music, when you're on the lawnmower, things like that. Those are high intensity sounds that can be damaging your hearing. A sound only has to be 85 decibels to cause damage and 140 decibels to actually hurt your ears. So that's a big difference there. Now, let's move to things that are a little more pleasant. Let's talk about pitch, how high or low a sound is. So I have a piano in the background because you hit each of these keys and they have a different pitch. Okay, and that's what makes our music, are all of the different pitches. Some pitches are higher, some are lower. Pitch is directly related to frequency. So each of these pipes on the pipe organ have a different pitch and they have a different frequency. Smaller pipes, higher frequency, larger pipes, lower frequency. Okay, and those make all of the different pitches, all of the different kinds of sounds that will come from a pipe organ. Now, ultrasonic sound. Ultrasonic sound is sound that is above our hearing range. A sound with a frequency higher than 20,000 hertz is above the human hearing range. And what I have in the background here is a dog whistle, because a dog whistle, when you blow it, you cannot hear it because it is ultrasonic sound. It is above our hearing range, but your dog can hear it. Okay, so that is an example of ultrasonic sound. And there are lots of sounds that are above or below our hearing range. Those that are below our hearing range are called infrasonic. And the last thing I want to talk about here is the Doppler effect. This is the change in frequency and pitch of a sound caused by the motion of the sound source of the listener. So let me explain. You have experienced this when you've heard sirens or even when you've heard a car go by you. Let me make the sound of a car. It goes going by you. It goes, "Meow," right? So we have an increase in pitch or frequency, and then we have a decrease in pitch or frequency. So where does that come from? Because I really don't think the car's sound really changes that much. So it has to do with our position to it. So what is happening is when a siren speeds toward an individual, more sound waves are pushed toward that individual every second. A buildup of compressions raises the frequency and the pitch of the siren. So you can see here with this police car, okay, it's speeding along, going after somebody here. What happens is these sound waves get all scrunched up. They have a higher frequency than the sound waves that are spread out behind the police car. So, higher frequency, higher pitch, lower frequency, lower pitch. So, that is what is going on. And this picture over here also shows it, um, taking out some of the distractions, higher frequency because they're closer together, higher pitch, lower frequency, lower pitch. So as the siren passes the individual, the pitch suddenly drops. So now you're back here behind the car. As the siren speeds away, fewer sound waves reach the person's ear. This lowers the frequency and the pitch of the sound. So lower frequency, lower pitch, because now you're behind the car. Okay, so if you are listening, to show that you're listening, I want you next to the information about the decibels, which hurt your ears. I want you to draw um, like ear protection. Okay, I want you to draw ear protection to show that when you're doing things like mowing the lawn or using different equipment, that you should have ear protection on to cover up your ears to help prevent hearing loss. So our objectives today were to relate amplitude to intensity and loudness, explain how frequency corresponds to pitch, and summarize the Doppler effect. So don't forget your 5 questions, and I will be back with one more video about sound.